Hi everyone. In the previous video we studied how to insert a node in a red-black tree. Now the main purpose of constructing a red-black tree is that a red-black tree is balanced. So if a tree is balanced, what it means is that its height is at most O of log n. Now that is what is true about red-black trees as well. That is, a red-black tree, if it has n nodes, its height is at most O of log n. Now we are not going to prove why this is the case, but we'll just accept this. Now given that the height of a red-black tree is O of log n, we'll study the insertion time. Now the insertion time, if you recollect, for a tree is O of height of tree. That was the insertion time for inserting a node, because you have to go all the way to the leaf nodes and then insert it. Therefore, as the height of a red-black tree is O of log n, the insertion time, the time is going to be O of log n. But there is one thing that we need to remember here. Whenever we insert a node in a red-black tree, the red-black tree property can be violated. Now, you will have to fix this violation, and these violations have to be fixed from the leaf all the way to the root. Now, how do you fix the violation? That is the next question that we have to answer. So, fixing a violation. If you look at the previous videos in this playlist, you'll know that we adopt two methods. One is coloring, and the other one is rotation. Now, both coloring and rotation, both of these are constant time operations. That is, one coloring and one rotation takes constant time, that is O of 1. Now, to fix one violation, you need finite number of rotations and coloring. So you need a finite number of rotations. Now what this means is that to fix one rotation, you are still going to take O of 1 time, because to fix a violation, you'll have to do a bunch of rotations and you have to color and recolor a bunch of nodes, but you only have to do it a finite number of times. Therefore, to fix one rotation, you will still take O of 1. Now, how many violations can be there? That's the next question. How many violations can be there? Now, to answer this question, we have to look at the height of the tree. Now, height of the tree will tell us how many violations are there, because we are going to start from the leaf and move all the way to the root of the tree. Now height is O of log n. And once again, we are not going to prove this, but that is the height of a balanced tree. Therefore, the number of violations is O of log n, is at most O of log n. I should be correct here, because that's the height. You might have to fix violations at each level, and each violation takes only a constant amount of time. Therefore, time to fix all violations will also be O of log n, because fixing each violation, as I mentioned, just takes constant time, and therefore fixing log n violations takes O of log n time. Therefore, time for insertion. You have to first take the time that you need to insert a node into a red-black tree, which is the same as inserting a node in any balanced tree. And as the height of the tree is log n, the insertion is going to take O of log n. Now, once you insert a node in the red-black tree, the height is not going to remain balanced. So we'll have to rebalance this tree. Now, to rebalance, we do rotations and recoloring, and what we just studied is fixing all these violations is going to take an additional O of log n time. Therefore, O of log n plus O of log n is going to give us O of log n. Therefore, the time to insert a node in a red-black tree, which includes fixing the red-black tree once we've done this insertion, is going to be O of log n. And this is going to be the case for all kinds of other operations as well. For example, we have not studied deletion, but deletion is also going to take the same amount of time because it's a balanced tree. With this, I'm going to conclude this video. Thank you for watching.